Hello there, I'm Pooja. Welcome back to Periodic Chemistry. In this video, we'll learn how to use Nernst equation to find cell potentials. If you're new to my channel and haven't subscribed yet, please subscribe and hit the bell icon to get notified about my upcoming videos. Okay, so let's start. We have seen about various forms of Nernst equation in my previous video, although we will be using this too, or rather the second formula in this video. Ecell is equal to E naught cell minus 0.0592 upon N log to the base 10 concentration of products divided by the concentration of reactants. This value is obtained by plugging the values of R, T and F in the above equation. Remember that we can use this formula only when it is mentioned the temperature is 25 degrees Celsius or standard conditions. Also remember that we can replace the concentration terms with the pressure when hydrogen or any gas is involved in the reaction and the pressure for that particular gas is given. Let's solve the example and make it more clear. Let's solve fifth question under question number 4. Calculate EMF of a cell at 25 degrees Celsius. Here answer is given. Let's see how to get to this answer. Given terms are the cell representation, where concentration of Zn plus 2 ions is 0.2 molar and H plus ions is 1.6 molars, and this is at 25 degrees Celsius. To find EMF of cell, we will be using two formulas. First one will be the Nernst equation, and second one will be the standard cell potential. We have seen about Nernst equation in previous slide, and we have learned about the standard cell potential in my previous video. E naught cell is equal to E naught reduction of cathode minus E naught reduction of anode. From the cell representation, it is clear that zinc electrode is an anode because it is to the left hand side, and H2 electrode is a cathode because it is to the right hand side. Let's see the solution step by step. Solution. As we have seen that left electrode is an anode and right electrode is an cathode, therefore zinc here will be an anode electrode and H2 will be a cathode electrode. Here we can see the charges on both the ions is different. That is, zinc has +2 and H has +1 charge. So we have to balance the overall reaction to make the charges equal so as to find the number of electrons or the value of N. I have discussed in detail about the balancing of the reaction in my previous video. You can click on the I button on the top left corner of this slide to watch that video. So here we can see that after balancing this equation, we get 2 as a coefficient for H+, and the charges here are balanced on both the sides of the reaction. The standard reduction potential of zinc is minus 0.76 volts, and for H2 it is 0.0 volts. These values will be provided in the exam, but I have taken these values from the electrochemical series. You can easily find the electrochemical series in your textbook, or you can use any search engine to study about it. I've also made a video about electrochemical series. You can watch that. Now let's calculate standard cell potential, which is equal to E naught reduction of cathode minus E naught reduction of anode. Just plug the values in this equation. 0.0 minus 0.76 volts. And we get reduction potential or cell potential for this reaction to be 0.76 volts. This is a standard cell potential. Now we will use this standard cell potential in the Nernst equation and find the cell potential. Let's make this equation more simplified. E cell is equal to E naught cell minus 0.0592 upon N log to the base 10. Products here are H2 and Zn plus 2 ions, and reactant here is H plus ions. Concentration of H plus is 1.6 molars. Concentration of Zn plus 2 is 0.2 and pressure for H2 is 1.8. That's why this H2 term is considered. Now let's plug the values. 0.2 into 1.8 divided by 1.6 raised to 2. This coefficient or the exponent term is from the overall reaction Yet we can see that H plus has a coefficient 2, while H2 and Zn has no any coefficients. Hence, 1.6 will be squared where the other terms will remain as it is. After doing the maths and the calculations, we get our final answer as 0.785 volts, which is the exact and the correct answer. Alright, so this was all about this part of electrochemistry. For further concepts, you can watch my other videos and also my previous ones. Please give your feedback and don't forget to hit the bell icon. Like, share, subscribe, and comment. Till then, thank you and stay safe.